Good morning, folks, and welcome from hot and humid New Jersey. We're very fortunate today. We're going to do a webinar on controlling LED lighting systems, and we've got Greg Galluccio, our Senior Vice President of Product Management and Engineering, to do this. I'm going to turn it over to Greg right now.
Morning, everyone. I do have some experience in controls for lighting systems. Prior to joining MaxLite, I worked with Leviton Manufacturing, which is one of the larger lighting control manufacturing companies. Today, I'm going to go ahead and talk about the basics of controlling LEDs, just three things. What are the lighting control options for a lighting system? In other words, what does control actually mean? What are we going to do with the LEDs? The basic components of an LED system that actually go to why controls can be kind of a challenge. So we'll talk a little bit about the electronics that are involved and what the challenges and available technologies are for LED lighting control. And what we won't talk about, we won't get into wireless systems because that's an entirely separate seminar, and we will put that seminar on at some point in the near future. But for now, we're just going to talk about wired controls and the ins and outs of wired controls. So there's a whole bunch of things you can do to control a lighting system. The simplest is to turn it on or off. So in that sense, we have timers and time scheduling products, mostly wall mount products that you would see offered in Home Depot and things like that, or wherever you might buy electronics. You could have a digital timer or a timer with step functions like you see in the picture there. Another is multi-level switching, and that could involve turning certain lights on and leaving others off, which gives you half the light level or a quarter of the light level that you might want. Or it might even be done inside the fixture, where you have a fixture with multiple lights and you're going to turn some of those on for say half power, half light, and turn the rest of them on, and you might have a multi-level switch that would enable that to happen inside the fixture. Next is dimming, where you have what we would call manual dimming, where the operator goes to a control and actually turns down the light level of a fixture or a group of fixtures. And one of the things that I'm going to point out here is that most of the dimmers that are field installed legacy dimmers were designed to control incandescent or fluorescent lighting loads, and that starting to try to dim LED lamps can present some challenges because of the legacy dimmers and how they were designed. Another way to control a lighting system is daylight harvesting, and that uses light sensors paired with either a switching or a dimming control that would take advantage of how much light is already in the room, ambient light from sunshine or windows or whatever, and control the lights accordingly. And then finally, we have occupancy sensors, which can also be vacancy sensors. I'll tell you what the difference is in a moment, but there's all different types of technology for occupancy sensors that will sense whether or not there are people in the room, and then control the lights, turn the lights off, or put them down to a lower level if there's no people in the room. By the way, the difference between an occupancy sensor and a vacancy sensor is that an occupancy sensor will actively turn the lights on as you walk into a room and then turn them off when you leave. A vacancy sensor requires the operator to physically turn the light on. This is relevant because of California's Title 24 requirements that say that you need to have a vacancy sensor, not an occupancy sensor. In other words, the person entering the room needs to turn the light on. And this is to avoid things like nuisance tripping, maybe an animal walking into the room and turning the lights on, something like that. So, occupancy sensors come in three main types. There are infrared, ultrasonic, and high frequency occupancy sensors. First, let me tell you, there's also different mounting styles. We have ceiling mount occupancy sensors, wall mount. There's sensors that can mount directly into the fixture. The picture on the lower right there shows one that is mounted to the side of what might be a high bay or a hanging linear fixture. You could also have sensors that may poke through and mount as part of the fixture housing. You could also have sensors that are mounted inside the fixture and can sense through the fixture enclosure. We'll talk about those in a minute. Finally, wall box mount, which is the top right type of occupancy sensor that senses from the wall and is mounted separately. So the different types of occupancy sensors. The infrared sensor is looking at heat signature, and it senses a change in heat signature. So it's looking at the room and saying, how hot is the room, and do I see a heat signature that's moving? it doesn't see around barriers. You have to have line of sight in order for an infrared sensor to work. That's one limitation on the infrared sensor, although what's good about it is that it usually is very fast to sense an occupant walking into a room because immediately it sees a heat signature change. But another problem with infrared is it can be fooled by a lack of motion. So small motion, like sitting at your desk and writing, may actually cause the sensor to turn off. And I'm sure we've all experienced being somewhere where maybe we're reading a book or sitting and writing, and all of a sudden the lights go off in the room. You got to wave your hands around and get them back on. That's most likely an infrared sensor. Next is the ultrasonic type of sensing, which sends out a sonic wave. Now, the good thing about ultrasonic, it's a little more expensive than infrared, but it can bounce around objects and detect motion that's not within its line of sight. So great for a restroom where you've got people in stalls that are not within line of sight of an infrared sensor. The motion sensor, the ultrasonic sensor will sense that. It's also pretty sensitive, so small motion will keep the sensor activated. So while you're writing or moving slowly around or turning in your chair, very often the ultrasonic can sense that. Great for stairwells, also for bouncing up and looking down. Another one is called a high frequency sensor. Some people call it a microwave sensor. A lot of times we try not to use the word microwave sensor because people get alarmed at the fact that maybe this thing is going to work like my microwave oven and fry something. And it's actually a very, very low power, high frequency signal that comes out of that sensor. The thing about a high frequency sensor is that it's able to see through a lot of materials like wood, wallboard, plastic, glass. And the advantage of this is you can mount it into a fixture that has to be sealed, for example, a vapor tight or something like that. And you can put it behind the lens of a vapor tight or a similar fixture like that, and it will see through it and be able to sense occupancy in the room. It will stop at concrete and thick metal and things like that. So the thing you have to be careful about with a high frequency sensor is that the specifier needs to understand that if you put this in a room that's constructed of wallboard and lumber, it's very likely that it can see through the wall and end up with false tripping. People walking through the hallway outside could fool the sensor into thinking that the light should be on in the room. So it needs to be utilized by installers who are familiar with the technology and understand how it works. So now that we've seen all the different types of sensors that are out there and the types of controls and the fact that you can do dimming, you can switch things half on and half off, how does that apply to the LED world, and where is it easy and where is it difficult? So let's talk about that. The best part is that compared especially to fluorescent lights and even incandescent lights, both of which do not like to be switched on and off, it will degrade a fluorescent light considerably to have that light turn on and off with high frequency. LEDs love to be turned on and off. You can turn them on and off millions of times a second and they won't degrade. You can turn them on and off all day. They're great for connecting to occupancy sensors in a high traffic area, like for example a restroom where people are coming in and out all day. The lights are going on and off all day long. Perfect. LEDs perfect for that. Absolutely no issues. So it makes them really compatible with sensors, timers, and other controls that switch on and off. Here's the hard part though. When you get into dimming, things get dicey. And it's not because LEDs aren't dimmable. Every LED pretty much is dimmable. It's because of the circuitry that we use to control the LEDs that's up front of the dimmer. So all LED lighting systems, you probably know, consist of an LED module or an array. That's a bunch of LEDs mounted on a board, or a single LED mounted on a board. But then there's some electronic circuitry connected to those LEDs that converts line voltage down to the DC voltage that you need to control the LEDs, and it also controls the amount of current going through the LEDs, which in most cases makes them brighter or less bright. And that device is, we know, as the driver, similar to a ballast in a fluorescent lamp, but call it a driver for LEDs. And so the issue with that is every LED itself can be effectively dimmed, but the driver may or not be dimmable. So it's the driver that's really controlling things for us. And when you mount a dimmer switch to the wall and then you connect that ostensibly first to the driver and then the LED, we just don't know what's going to happen. So the problem is there's so many different types of driver design, and the drivers are like snowflakes. There's millions of them out there, and no two of them are alike. And if you're a dimming device manufacturer, like say Leviton or Lutron or any of the others out there, the huge challenge you have is you don't know what you're connecting to in terms of circuitry. And there's ways to try and optimize what you're building, but you cannot ensure compatibility with anything that's out there that's an LED driver right now. So how do we as users, how do we cope with that? So let's see. First thing they have to do is understand what the different control methods are. So some drivers might not be dimmable at all. So no matter what kind of control device you connect to that driver, you won't be able to dim the LEDs. Now, when you see an LED type product like a fixture or a light bulb that says that it is dimmable, that doesn't mean it's necessarily going to be dimmable with the type of dimmer that you have, because there's at least 6 different types of dimming that are common and another 60 that are not as common that we won't even go into. But here's the different types of dimming that we run into most often. First of all, there's phase control dimming, triac dimming, which is really most of what's mounted in the walls in our residential applications. So the dimmer that's on the wall in your house is most likely a triac dimmer. And I'll talk about how triac dimmers work in a little bit. In a lot of commercial applications, we see 0 to 10 volt dimming, and that's most prevalent out in the fluorescent world, in office situations, any kind of commercial hospitality and things like that. We see 0 to 10 volt dimming. There's something called fluorescent 3-wire, which was, sort of a proprietary design that was out there. You don't see that as much anymore now that fluorescent is phasing out. DMX is another control system mostly used to do color control and some fancy light strobing and things like that. A lot of that in the entertainment industry, but it does bleed over into the regular commercial world. DALI, which is a digital addressable lighting interface. That's what DALI stands for. It's a European design, very, very popular in Europe. Started to catch on in the United States a bit, so people start asking for DALI here and there. Kind of difficult to commission, and I'll talk about commissioning later, but it's something that you see mostly in Europe. And then electronic low voltage dimming, which is used in low voltage situations where you have perhaps a transformer leading to some track lighting that operates at a lower voltage, and the dimmer is tuned to work well with a transformer like that. So I'm not going to get into a real deep technical discussion of all these different types of dimming, because the thing you really need to know is whether or not you're using a dimming controller that is matched to the driver of the LED system. So let's start with phase control dimmers, which are the kind of dimmers that are very popular in residential in the wall. And what a phase control dimmer does is it actually chops up the AC waveform so that the amount of power that's being delivered to the light is less than it would be under normal conditions. It's not lowering the voltage to the lamp or the light fixture. It's changing the amount of power going to the fixture. And effectively, it's almost like switching it on and off very, very quickly. And when you switch an incandescent light bulb on and off very, very quickly, there's what's called a hysteresis effect. It doesn't turn all the way off, because it's only got 1/60th of a second to sort of cool down. And so you don't see it actually turning on and off, because it really isn't. And so when you turn it on and off really fast, it dims. It effectively dims because less power is going to it. And that worked great for incandescent bulbs. The problem with LEDs is that when you turn them on and off really fast, they actually turn on and off really fast. And if you turn them on and off too slowly, which is down to like 1/50th of a second, 1/60th of a second, can see that. The human eye can see that, and it manifests itself as flicker, which can even be dangerous in certain situations for people with medical conditions that might be responsive to things like flicker. So it could become a problem for certain LEDs. Then a 0 to 10 volt is what I said is prevalent in the commercial world, and the way that works is the driver is specially built to have a second set of wires coming in that are a control voltage. And the control voltage comes from a 0 to 10 volt dimming system that's either mounted to the wall or mounted to a sensor or something like that. And it talks to the driver, and it's very simple. Basically, if it sends 10 volts to the driver control circuit, the driver will operate the lights at 100%. If it sends 9 volts, it'll drop it down, hopefully to 90%, but not always. If it sends 8 volts, 80%, etc. It's not always that linear, but the concept is there. The lower the voltage that goes to the driver, the lower the light output that the driver will create in the fixture. And obviously, if the driver is looking for a 0 to 10 volt dimmer and you put a triac dimmer on the circuit, it's not going to work. So that's the big point I want to get across, and vice versa. So, again, you don't really need to know exactly how they work, but you do need to know that 0 to 10 volt systems need to have a 0 to 10 volt dimmable driver and can only be used with 0 to 10 volt dimming control, and the same for triac. So the second thing is that there's different wiring schemes for these different types of controls. Where you see phase cut in that diagram, that's also triac dimming, so please don't get confused by that. But phase cut is triac dimming. The nice thing about triac dimming is that you only need the standard hot and neutral lines going to your fixture. You don't need additional wires. So if you've got an existing construction where you want to put in dimming LED fixtures or dimming LED light bulbs or something like that, usually the triac dimmer is going to be your best bet, and you need to go with a triac compatible LED fixture. However, for performance purposes, 0 to 10 volt dimming tends to work better with LEDs. The dimming is smoother, less chance of flicker, things like that. So if you're fortunate enough to have a situation where either you've got the 4 wires already running in your installation, or you have a new construction situation or an easy wiring situation where you can add the control wiring, 0 to 10 volt is usually a better performing system. And I'm just showing fluorescent 3-wire and dolly there to show that there's even other types of wiring configurations that you might need if you find yourself in a situation where you were faced with a fluorescent 3-wire dimmer or a dolly dimmer or something like that. So use the same control type for the driver, but then it doesn't even ensure compatibility, unfortunately, if you use the same control type. And this goes back to my comment before where there's a million drivers out there, and there's even a million different 0 to 10 volt drivers out there. And there has, to date, there's never been a standard written that says if you're going to design a 0 to 10 volt driver, it needs to respond to a 0 to 10 volt signal in the following manner, and sets those standards very clearly. So what we've had out there is the Wild West leading up to today, where I could say I've designed a 0 to 10 volt driver, but when I send 9 volts to it, I'm only getting 50% light. Or my dimming curve is not exactly linear, things like that. Or maybe in some cases the driver performs this way. As you get down to halfway on your dimmer control, the light just shuts off. And you'll see things like that happen all over the place. So now what do? Let's go to the next slide. Here's some of the possible compatibility issues that you might find even when you're using the correct combination of controller and light fixture. One is the dimming range. So in many cases, the lights will not dim all the way down as you go down. They might go down to 20%, they might go down to 30%, and then suddenly shut down. The reason is because LEDs need a certain amount of voltage to actually run, and when you get down to levels where they don't have enough voltage to run, unlike incandescent lamps, which really nicely dim down all the way from 120 down to 0, LEDs at some point are just going to shut off because they don't have enough electricity to run the circuit. So it could happen that they're dimming very nicely, then suddenly shut off at a level that you would rather be able to go down further. Flicker, we talked about before, when you have, especially in triac dimming situations, where you're chopping up the waveform in order to get the light to dim. If you chop it up too slowly, or if the LED is very, very sensitive, you could have perceptible light level modulation, which is flicker, and that can be very disconcerting to the customer. Another thing called dead travel, where you start off at 0, let's say on your dimmer, and you start to move it up and nothing happens until all of a sudden the LEDs turn on, and that goes to the voltage situation I talked about before. It could also happen at the top end of the travel. So if you've got a slider all the way at the top and you start moving it down, nothing may happen for a while, and then all of a sudden the LEDs start to dim at, say, when you get to the 70% point. Non-linear dimming, so now you move the dimmer a tiny bit and the lights dim a whole lot, and then you move the dimmer a lot more and they hardly do anything. So you've got a situation where it's not linear from one side of the slide to the other as you go down or up. You could have dropout, you could have ghosting, which is a big problem, where very often when you turn a 0 to 10 volt dimmer all the way down, it doesn't go down to 0 volts, or there's still voltage, for example, going to the lights. Now, when you had the incandescent and fluorescent lights, that was usually not a problem because they required a certain amount of voltage to start up. An LED light can often start up with a very, very small amount of voltage or current. And sometimes when you turn the dimmer all the way off, the light stays on. Then you have to add an actual switch into the system. And even if you add a switch, some switches can let leakage current come through. That's enough to actually leave the light on. So that can be a problem. And then finally, audible noise, where you start to dim down and now you hear buzzing from the fixtures or the light bulbs. And that can happen with a driver design that is not carefully configured for dimming. So you need to get not only the same type of dimmer and the same type of fixture and match them together, but you have to make sure that they're actually compatible in terms of performance. And now we run into the question of, what does compatible mean? If the dimmer works really well but only dims down to 20%, is that compatible or is it not compatible? Some customers in certain situations might not care. In very much in commercial situations where you're putting a dimmer in a conference room or something like that, dimming down to 3% is not critical. Whereas in a residential or hospitality situation where they want to create a certain ambience, or they want the lights to dim in a certain fashion, then dimming down to 30% and shutting off is not going to cut it. So the term compatible can mean different things to different customers. There are standards coming out for example, in California under Title 24, where they're driving the performance down to 1%, where they're going to require that the fixtures dim down to 1% under the right conditions. We'll see that under regulation, but you probably won't see it in unregulated areas. So it's up to the specifier to decide what's okay in this situation. And then what if you have a little bit of flicker at the bottom end? Is that okay? It might be okay for some people, it might not be. And what is a little bit of flicker compared to a lot of flicker? It's a very subjective measurement. We don't really know. So all these different considerations have to be taken into account. Another thing is the number of lamps. This one confuses and confounds people all over the place. Some dimmers will require an actual minimum load to operate. So you could put 1 or 2 lamps on the circuit and they don't work at all. Add a third lamp and all of a sudden it works great. That's a tough one, especially for contractors who are trying to specify a system. The opposite could also happen, where you've got 5 lamps, 6 lamps in the circuit working great. You add a 7th lamp and the whole thing just shuts down or doesn't want to work correctly. Things start blinking. Again, it's almost like voodoo, but more and more the controls that are coming out today are more and more sophisticated, and they're heading off a lot of these performance issues. But let's talk about how we might choose to specify things so that these don't happen. So the tips for best LED control performance. Number 1, make sure the types of control technologies match. Number 2, get information about the dimming range and the dimming performance of the lamps, especially paired with the kind of dimmer that you want. A lot of the controls people actually publish that information. As new lamps and fixtures come out, they test them, they publish the information, and then choose your compatibility requirements based on the application. If you know that you need 1% dimming, you're going to have to maybe spend a little more money and be a little more discerning in your combinations of dimmers and controls. If you can do with 20% dimming, you might be able to offer a much more cost-effective solution. Determine the minimum and maximum load requirements. And actually, what I suggest in more complex situations is to actually mock up some dimmers and fixtures together before you go ahead and do an installation. Once you have that stuff up in the wall, it's really hard to tear it out and fix it and put something back up again. So that's it for my comments today, and if there are any questions, please direct them to the attention of contact information on your screen. Thank you.
Thank you, Greg. One of the things we also have is on our data sheets, MaxLite puts some dimmers that they have tested for compatibility. So it's always a good place to start is to take a look at the data sheet. If you have a particular dimmer and you don't see it on the data sheet, then reach out to our technical support team here at MaxLite, and we'll be able to tell you yes or no if we feel that that dimmer will work. We're going to stay on for a few more minutes here, so if there are any questions that come in, we will address them. Thank you for your time.